Hello, geometry students. Today we are going to learn a new lesson, 17.3, on similar figures. But before we do, I'd like you to start with this warm-up. So we are going to dilate this triangle by a scale factor of 4 with a center other than the origin. So the first thing I want you to do is pause the video and make yourself this chart where you have the original point. You're going to subtract the center, multiply by the factor, and add back the center. List each point below it, A, B, C. Pause your video, do that right now, and then press play again, and I will talk about what to do next. Okay, next I want you to remember that when we are dilating an object, we're either enlarging it or reducing it. And since it's a scale factor of 4, this is going to enlarge. Now, if we were dilating from the origin, if you remember, we would just take each of the ordered pairs that we listed and multiply them by 4. But since that's not what's happening, it's a dilation with the center at 3, 1, we first have to subtract the center, then we have to multiply by our scale factor and add it back. So you should have your original points listed here. And then remember, we're subtracting the center point, which is at 3, 1. So you're going to subtract 3 from each of your x's and subtract 1 from each of your y's. Then you're going to multiply your results by 4, and then you are going to add back the center. So press pause on your video, finish that, and when you're ready for the answer again, press play. And here are the answers. A, once it's moved, will be at 19.5. B will be at -9.29. And C will be at 3, 1. Remember, we're subtracting 3 from each of our x's. This becomes 4. This becomes -3. That becomes 0. Then we subtract the 1. We take each of these and we multiply by 4. And after that, we're going to add that center back. So add 3 to each of my x's, and then add 1 to each of the y's. Notice that my point C actually stayed put. That's because the center of this dilation is 3, 1, and the center stays right where it is. So open your notes. And we are going to talk about similar figures. This is 17.3, and we're working towards our fluency check number 11. So here's the first page of your notes. And if you recall from first semester, the definition of congruent figures, they are figures with corresponding sides congruent and corresponding angles congruent. Similar figures are different. So let's look at two triangles that are similar. Triangle ABC is similar to triangle DEF. Remember the word similar in math, we write it's this little squiggle mark. So I'm going to compare the corresponding side lengths of ABC to DEF. Now AB corresponds with DE. AB is here, and you'll notice DE is here, and both of them are the largest sides of my triangle. The largest side is going to compare to the largest side. So 10 has to compare to 20. The next side I'm going to look at is side BC compared with EF. BC is here, EF is here. Notice they are both the smallest sides. So let's look at the ratio formed by those sides. 6/12. And then the last two sides are AC and DF, and that is 7/14. And I wrote equal marks between each of these because when I have corresponding figures, I know the ratios of their sides are equal. So in this case, my similarity ratio is 1/2, and my scale factor is 1/2. The next question is, what do you notice about the corresponding angles? And as I had said before, when you have similar figures, the corresponding angles stay congruent. It's just the sides that change size. Next, we are going to add this to your word wall. Figures that are similar, and remember it's the squiggle mark that means similar, have the same shape, but not necessarily the same size. You'll notice this is written in your notes. The definition of similar figures is that figures with corresponding sides are in the same ratio. And corresponding angles are congruent. So looking below at the figures drawn, triangle 1 is similar to triangle 2. We can write it like that. Triangle 1 here is not similar to triangle 3. You can see that the shape is different. Now let's look at these rectangles and decide if they're similar. They're going to be similar if their sides are in the same ratio and their angles are all their corresponding angles are congruent. And as you can see, since these are all 90-degree angles, we don't need to worry about that. All angles here are congruent. But we do need to look at the sides to see if they're in the same ratio. You compare the biggest side to the biggest side. So 30 divided by 20. Big. Now I have smaller sides, 18 and 12. I've got to see if that is the same ratio. And we have two other sets of sides, but again, it's a rectangle, so opposite sides are congruent, end up with the same ratios. So 30 over 20 simplifies to 3/2. 18 over 12, both are divisible by 3. That's 6 over 4, which then also reduces to 3 over 2. So the ratios are the same. So since the ratios of the sides are the same and my corresponding angles are congruent, I would say yes, these are similar. And we should write a similarity statement, A, B, C, D. And we want to line that up with the corresponding angles, H, E, L, P. Ooh, help me. So notice A, B corresponds with H, E. B, C corresponds with E, L. The order matters. Next, I have two pentagons. I don't really like that this symbol is drawn here, but that's in your notes. Just cross it off. Let's label these A, B, C, D, E, F, G, H, I, J. Okay, we really need to know what sides correspond to which. So I'm going to give you the similarity statement, and this should have been given to begin with. ABCDE corresponds with FGHIJ. So I have the corresponding angles lined up. So we are given that these pentagons are similar. So I know that their sides have to be in the same ratio and their angles have to be congruent. And I'd like to solve for X and Y. So I only have one set of corresponding sides, which I know, which are 8 and 15. So all my sides are going to be in that ratio. 8 over 15 has to equal 6 over X, following that pattern. So I am going to cross multiply and solve. 8 times X equals 6 times 15, which is 90. Divide both sides by 8. X is 90 over 8. That's my answer for X. Now, next, let's compare 8 over 15. Except this time I'd like to solve for Y. And AB corresponds with FG. So 7 over Y. Again, we're going to solve for Y by cross multiplying. 7 times 15 is 105. Divide both sides by 8. you will get 105 over 8, and that's what y is, and neither of those fractions simplify. So when you know you have similar polygons, you can use that similarity to solve for missing side lengths. Let's look at number 4 in our notes. So Kate is about to meet with her final client of the day. She needs to create a wall mural. She can measure the length of the wall, but not the height. She has a prototype picture and knows that the wall and the picture are similar rectangles. Kate needs to find the area of the wall. So she has the wall. This is the big wall that she's going to write on. And she has this prototype. She knows the prototype is similar to the rectangle of the wall. So now it asks which sides of the rectangles are corresponding. So you can see this is the bottom of the picture, and this is the bottom of the picture over here. This side corresponds to that. The length, the height, is this side. This is the height of the picture there. Those two sides are corresponding. So it says which sides of the two rectangles are corresponding. I would put bottoms correspond. And sides correspond. Let's not call it sides. Heights correspond. Okay, next part B says, write two different proportions that can be used to find the height of the wall. Okay, so let's call the height x. So I could compare my corresponding sides. 14 over 31.5 equals x over 18. But I can also write a different proportion. Now, it's all about following a pattern. Here I went bottom is to bottom as right is to right. I can also go bottom is to right as bottom is to right. And I will get the same answer. So 14 bottom is to right as bottom 31.5 is to right. Now, I also want you to notice I had different units going on here. So I could have switched my units to all be matching, but it's really not necessary. I have 14 feet is to 31.5 inches. Feet is to inches as feet is to inches. So when I solve for x, I will get my answer in feet. If I look at my other ratios and proportion, I'd have 14 feet is to x feet as 31.5 inches is to 18 inches. My answer for x will be in feet. Let's look at part C. It asks the question, could you use the proportion x over 18 equals 31.5 over 168? Now, one thing I didn't write here is 14 feet is 168 inches. So they just changed everything to inches. And again, it's not necessary so long as you keep track of your units. Now let's look. They did x over 18 equals 31.5 over 168. That cannot work. They did big is to small as small is to big. It would have to be x over 18 is equal to 168 over 31.5. Now, if I were to solve this proportion, what I would find is it would give me my answer in inches. So let's just go ahead and do that so you can see how that works. So cross multiply, and I would get 31.5x equals 168 times 18, 3,024. and then divide both sides by 31.5. And that's 96. This is in inches. That's the height of my wall in inches. And earlier, I had solved, and let's cross multiply down over here. 31.5x equals, let's cross multiply 14 times 18. That's 252. Divide both sides by 31.5, and you find out that this is 8 feet. Well, it just so happens that 96 inches, if I divide by 12, is 8 feet. Either way, I get the same answer. That's the height of my wall. The next question is, what is the area? Remember, the area of a rectangle is equal to the base times the height. My base here is 14 feet. The height is 8 feet. And 14 times 8 is 112. And that's 112 square feet. Let's move on to problem number 5. I have rectangle DEFG similar to triangle WXYZ. And it asks which sides must be proportional. Write the appropriate proportion. So that would mean DE would correspond to WX, my first two letters over my first two numbers. EF, second and third letter compared to XY. And FG compared to YZ. And DG to WZ. So it's all about the similarity statement. The order matters. First two letters over first two letters. Back two letters over back two letters. So it tells us what angles are congruent and what sides are proportional. Number 6, these are two separate rectangles. They're not labeled. And it says, if the rectangles are similar, what is the value of x? Notice I have this length here and length, width, and width. So I'd like to compare my lengths, 12 over 18, as compared to x over 9. Again, we can write the proportion in different ways. I chose to say bottom is to bottom, as right is to right. I could have also said bottom is to right as bottom is to right. Either way, I'm going to get the same answer when I solve. Let's go ahead and solve this. I'm going to simplify my fraction just to make my math a little bit easier. 12 over 18 simplifies. Both 12 and 18 are divisible by 6. So that's 2 over 3 is equal to x over 9. Then I can cross multiply. 3x equals 18. Then divide both sides by 3. X is 6. I've posted some problems for you to do as homework. All you need to do are problems 7, 8, 9, and 11. And I'll see you next time. Have a great day.